Here is an overview of how the code works in the Wacko cracktro. We saw a very early version, which scrolled unintelligible text on a wonky background. It quickly evolved and was finished in no time. One problem that I had was raster interrupts. The screen was divided into three main areas. The top part consists of a character-based logo with its own character set stored at 2,800. The middle part consists of a 3x3 character-based scroller with its own character set stored at 3,000, and the bottom part consists of another custom character set stored at 3,800. The character sets were done with CharacterPad. You can see some of the problems that I had with raster timing here, but I managed to overcome them by being careful with the timings and by using the raster interrupt to set a flag that told the main loop of the program outside the raster interrupt to execute the scroller code. Even so, screen tearing on the scroller forced me to use double buffering, which involved copying the scroller from screen 400 while currently on C100 and vice versa. The scroller works like this. We create a 3x3 custom character set, or in this case, use a ready-made one that comes with CharacterPad. We store the 120x3 map at 3,400. We use D016 to scroll the screen left by 7 pixels. While this is happening, we are copying the first column of the 3x3 character into C100. Once we have done that, we switch to screen C100 and start copying the second column into 400 while scrolling, then switch screens again. This is what the code looks like. While using D016 to scroll, this routine copies the screen from 400 into C100 but shifted left by 1. You can see that the -1 in some lines has shifted the information left. LDA loads the information into the accumulator and STA store the accumulator into memory. After this routine has shifted all of the characters left by 1 character or 8 pixels, this routine copies the next letter of the scroll text onto the screen. Because the text is 3x3, we need to copy each column individually. This first highlighted section selects which part of the scroll text message to load. Since we are dealing with 8-bit computers, my message of over 255 bytes is split into 2. Once we select the correct half of the message, we load a character into the accumulator and check that the value isn't 0, which means go back to the start of the message. This piece of code loads the second half of the text into the accumulator. This section checks to see whether the character code is for a special character, such as a space or full stop. If so, it loads the correct value into the accumulator so that we point to the correct part of the 120x3 map stored in memory. The correct part of the scroller map is found for alphabet characters easily. Since each letter is 3 characters wide, we simply multiply the return character code by 3, and we find our letter in the scroller map. The which bit variable simply tells which column of our 3x3 character to copy into the screen. The which screen routine is called and examines D018 to see which screen to copy the character into, and then copies it. Note that back in our main routine, 120 is added to the 0-page low byte at address 23, so that the next row of our character can be pulled from the scroller map and copied onto the screen. We now copy the rest of the first column of our character onto the screen. This part now increases which bit so that the next row of the letter can be copied after the screen is shifted left. The next character of scroll text is selected. We tell the routine to start at the first column of this new letter. If we reach the end of the scroll text, we need to make sure that it loops back to the start again. The mutating pattern at the bottom of the screen is called from a raster interrupt. You can see there are 2 patterns that I coded, mutate and mutate 2. The dots are a custom character set made in CharacterPad, and the cycling of the dots from small to large and back again is done in the main loop of the program to avoid having too much in the raster interrupt. The first version of my routine was terrible, and I remembered being told to do my calculations at compile time rather than runtime, so I ended up hard coding in the circular arc coordinates. This part selects the correct arc radius to draw. We load the arc coordinates. The arc coordinates look like this. The returned arc coordinate in the accumulator is transferred to the Y register. If it is 0, we have reached the end of our data and we return from the subroutine. Since we are using 8-bit registers, when encounter a number larger than 255, it is split in two. Seeing a value of 255 says add the next value with this one and then plot the point. This part of the code does that. This part of the code copies a dot into the screen at the correct spot. I found a really weird bug while coding this cracktro. If we use DECD016 to scroll the screen using this register, it works fine until we use this code within a raster routine. Then it doesn't work anymore. In order for the code to function within a raster interrupt, we need to decrease a variable that stores the last 3 bits of the register and then add this back into the D016 register. I challenge anyone to prove me wrong, as this bug has caused me a lot of headaches.